Hi friends, welcome back to the Raytracer challenge by James Buck, implemented in Rust, a language I've never used before and am learning as we are going along implementing this thing. This installment of the series is an extra or a bonus episode where we are not going to implement something specifically from the book, but we are going ahead and trying to make something better that we have already implemented before going further along. Just because I want to find out how things work a little and how we can make things better a little. If you want to follow along the code, you can find everything you need in the description down below, where a GitHub link, for example, is placed, where you can download and run all the code yourself, play around with it and get to know Rust as well. So, what are we going to do in this session? We are actually trying to make things a little bit faster. Faster is always better, isn't it? So the last time we finished up chapter 5, which ended by essentially really ray tracing something. So I was able to do something like this. Cargo run ---- bin chapter 05. And now the system goes ahead and ray traces and throws rays into the scene and intersects them with a sphere. And as you can see, this takes quite some time because it has to ray trace and fire over a million rays. So let's check the output of this. The output essentially is this nice sphere here, which is only the silhouette of the sphere, as we haven't implemented lighting yet, which would make things even slower because we need to bounce off other rays from the surface against lighting and stuff like that to determine how the projection should be lighted. But we will see that in the next episode. This one is about how to make things faster. And even though I really like this result, as we have done something really nice by reaching a really nice step in our work by having the first sphere ray traced, I want to speed it up a little. And the idea behind speeding it up is not optimizing Rust code, which is essentially not my area of expertise right now, because I've not worked with Rust before. And of course I could now find out what profilers there are, and I could profile our code and optimize it. And maybe later on we will do this, but not now. The first thing we are going to try and do, because that's the most low-hanging fruit of all, is to parallelize this process. Because ray tracing is heavily parallelizable. We can do essentially an arbitrary amount of pixel calculations in parallel. So we could go ahead. Currently, we are doing everything in one thread. And this means I'm using only one of my CPU cores. This workstation here has essentially 8 cores, which it can draw its calculation from. So why not speed things up by parallelizing it? We should essentially be more or less 8 times as fast then by simply doing the calculation in parallel. And this is essentially what we are going to try and figure out here. But first, we should create a new branch for our work to reside in, because I don't want to clutter the main branch if our experiment shouldn't work at all. So let's check out a new branch, call it experiment. Yeah, I guess parallel. And there we go. Now we have a different branch, and the first thing I'm going to optimize away here is, I guess, I'm removing this ppm output, because we have a much faster PNG output currently, and the ppm is quite slow. We can write it, it works, but for larger images, and we will be testing this rendering with larger images, it is quite slow. So we can remove this and commit this as a first operation. Git source bin chapter 05 git ci removed ppm output from chapter 05 example. The ppm output is quite slow currently, as it does a lot of copying data around during the export process. This could of course be optimized, but for now we have a quite fast PNG output, which works well for us. Therefore, the ppm output is not really needed at this point. We may revisit this in the future. So why did it wrap this kind of strange? Okay, I don't know, I don't care. Let's just commit this. So now we have removed the ppm output. So yeah, let's actually go ahead and try and optimize this a little, or better said, parallelize it. So how does this work in Rust? I've essentially no idea. What we want to do, I guess, is we want to somehow put this loop into an arbitrary number of threads which are processing those rays in parallel and then writing those pixels to the same canvas. So we need to figure out, I guess, how to spawn multiple threads, and in the end how to combine those information in the canvas in a thread-safe way, because I doubt that our canvas like it is thread safe, so that multiple different threads can write into it. So I guess we start, as always, by Googling Rust multi-thread iteration, maybe? How can multiple threads share an iterator using threads to run code simultaneously? So yeah, let's take a look at this. Using threads to run code simultaneously. I guess I will have to read a lot of stuff before we can come back and do something. So let's start with that. Okay, I guess we could implement this using the spawning of different threads. It is easier than I thought at first, and it seems to me that we could transfer ownership of the canvas, which we don't really want, but we could essentially maybe transfer ownership of only one color value that we are then transporting out of the thread. But essentially I don't want to spawn a thread for each ray, I guess. I think there might be quite an overhead to spawn a thread for everything. I'm not sure, but in other languages it usually is quite the overhead to spawn a thread. So I'm questioning if we really want to spawn or to handle this on our own. The question is there something, maybe something like a parallel iterator or something like that in Rust? Is there something like this? Data parallelism Rayon, a data parallelism library. Yeah, let's check this out. Because essentially we only want to parallelize our iteration. So what is this? Rayon is a data parallelism library for Rust that is extremely lightweight and makes it easy to convert a sequential computation into a parallel one. Okay, this for now this sounds like exactly what we want to do. It also guarantees data race freedom. Oh, nice one. You may also enjoy this blog post about. Okay, let's open this up in another tab there for later use, which gives you more background and how it works. Or this video, okay. API documentation. Let's open that up as well and let's check. Rayon makes it drop dead simple. Oh, I like that. Makes it drop dead simple. Drop dead simple is okay for me. Usually you just change your iter into a par iter and Rayon does the rest. Okay, what? So Okay, so they are using an iteration function and you simply give it this one and then it will do this in parallel? Do I understand this right? How to divide your data into tasks. It will dynamically adapt for maximum performance. Okay, if you need more flexibility than that, Rayon also offers the join and scope functions, which lets you create parallel tasks on your own for even more control. You can create custom thread pools. Is it really this simple? Maybe we just should check it out and kind of try and then do this. Yeah, I guess before we can even test this, we need to convert our rendering example into one that is using an iterator. So maybe we should do this. Maybe we should just convert this iteration here into an iterator. The question now is, we could of course do this line by line. Like we have this outer iteration and then in here we are dividing this up. Should be reasonably fast, or we have an outer iterator. But can't we kind of create one iterator iterating over the whole thing? I guess I could just... Couldn't I do something like, isn't this here essentially an iterator? Can't I do something like dot canvas size, have parentheses around this and then call iter on this? No, it actually is an iterator, so I should essentially be able to... is there something like for each in Rust? Let's see. What happens if I do something like I here and then just put this there and tell it to print line I. Does this work? At least it doesn't complain. So let's I just want to test if this works. Cargo run chapter 5. Okay, it printed out all those values. So that worked, but it had okay, too much values. Let's comment this out. I can't scroll back this much here in the terminal because there was a oh yes, we have an unused import now. Of course we have. We removed the ppm export, so we don't need this anymore. Let's actually amend this to the let's amend this change to the yes, we want this one. No, we don't want this one. And let's amend this one to the remove ppm output commit. So yeah. Okay, so we can actually kind of iterate, it seems. Oh, this is an iterator. So yeah, but if this is an iterator, can I call iter on an iterator, or how does this does this stuff with the Of course, this does not work. So maybe let's see how we can maybe let's load this this how was it called? Rayon. I have no idea how this is pronounced. Maybe it's really from Rayon. It's I have no idea. Okay, so let's search for this one. Search Rayon. Let's install this dependency, I guess. So there we go. Let's get this one and let's put it into our dependencies here. So yeah, now this is installed, and then we should be able to, where was this? Use Rayon prelude. Okay. So maybe just put this here and Yeah, unused import. Okay, so now we have this input iter. Yeah. So didn't I open up this? This was a blog article about this. Yeah. So maybe we can get some more information from that here. Into iter method into wait, par iter or into par iter. Can we do this? Can we just wait a second? Can we do this? Is it that simple? Can I say into par iter here now? Okay. What? Does this actually run and compile and okay, for now, let's, I guess, let's comment out all this real ray tracing here because I want to, of course, implement it later. But for now, let's just check if this works. Cargo run chapter 05. Let's see. Okay, it obviously executed this in then more random order because yeah, it must have done it in multiple threads, but did this actually work? Okay, so let's do something different. Can we access a variable outside of here? Let's check this. Let mut let mut I start with the 0, and then we could yeah, we could print something, and we could simply do an I equals I plus 1. So each of those. Oh, wait a second. We called it I there as well. So let's call this run count maybe. And let's do run count plus 1. Cannot assign run count as it is a captured variable in an fn closure cannot assign. Okay, so how do we get data out of there? Rayon and mutexes. Okay, let's help. Okay, so there is a mutex in the default Rust standard library. So okay, so let's just check this. Okay, so we have this. Does the mutex need to be? Doesn't seem to be mutable. So let's call this one here and say we want a new mutex here. Is it actually, is it new? It is new. So let's do a new mutex and let's simply put a 0 in here. And we of course need to import this one. And now let's just, let count, or is it then, do they, yeah, let mut count the run count mutex dot, what is it called? Log, I guess. Yeah, we want to log it, we want to get it. So let's do this one. And once we have this, we can do count equals count plus 1. So cannot add an integer to mutex guard integer. Okay, maybe is there. Maybe we need to tell it here what this mutex holds because I want it to hold a usize. Okay, doesn't make a difference. Cannot add integer to std result. Standard sync mutex guard usize sync poison error. What? Oh, I guess this could fail. Okay, so yeah, but Yeah, but I thought they were just accessing this vector then. What is a Okay, maybe we need to read up on mutexes. So what does this lock actually give us? It gives us a lock result with a mutex guard in it. And mutex guard is what, essentially? Array implementation of a scoped lock of mutex. When this structure is dropped, the lock will be unlocked. Yeah, okay, I understand that. The data protected by the mutex can be accessed through this guard via its deref. Okay, so we are essentially getting something back which we need to, I get it. So I need to deref this, and once I do this, this guard will give me the real value. So we have this guard back. Ah, okay, now I understand how this is implemented. We're getting this guard back. We are getting this mutex guard back from the mutex, and inside of it is a reference to the real value. And as long as this mutex guard exists somewhere, is allocated, is in scope, so it's on the stack, no other lock can be given such a guard. So any other thread has to wait. Yeah, so maybe let's check if this works. Okay, so it is still doing parallel work here, I guess. But now we should, in the end, have some value within the... yeah, I guess we need to... Oh, no. I guess we need to... We don't need a mutable one of those there, because we only want to read it. Let's print this out. Let's do print line. At the end, let's say ran times. And there we put the dereferenced guard, which is count. So let's check. And essentially, it really ran 1024 times. So this actually really seems to work. Maybe we want to... Could we put our canvas in a mutex and just write the pixel data? So if this is working, okay, let's try this out. If this is working, let's let me comment this one out as to have it there as a reference. So let me comment this one in again. So if this is, that would be fantastically easy. I would love this. Okay, so let's for example do something like, let's do it by the, let's split up the, I guess we are doing this, and then we are putting those here, and we are saying, okay, get me a par iterator of that. So get me a parallel iterator of that. And then we are simply putting the x within this function. This function takes 0 arguments, but 1 argument was supplied. Why? Wait. That's strange. No, there we should have this one. But why is this function takes 0 argument? Wait a second, didn't we? Oh no. I need to create a parallel iterator, and then I do a for each. So yeah, it cannot access the canvas here. So let's let's, I guess, put our canvas. Let canvas mutex mutex new, and let's put our canvas in there. Can we do this? I guess we can. And now if we need the canvas, we can do like let canvas mutex, canvas mutex. We are telling it we want to lock it here, and we are unwrapping it. And now we should be able to dereference. Okay. Why is this not working now? Oh, do we have to define this mutable here? Ah, okay. Okay, wait a second. Why is this cannot borrow canvas as Okay, it's actually within the error message. I just not read this right. It tells me not that it cannot borrow it. It tells me that it needs it to be available there. Oh yeah, and of course after we have okay, maybe we should make something clear here by moving it into the mutex in the first place. So I guess we want I guess we might want to have, give me a second here, we might want to put this in here. So like we have a canvas new, which we really put in here, so that it is not available outside. And then cannot call method power an ambiguous numeric type integer. Did we do something wrong here? Oh, did it get the information about what canvas size is by, I guess, by using this information here? Okay, it inferred which numeric type this is, which kind of numeric type by the usage here, because then it can only be what did we define here? Why I'm not able to click this, I don't know. We defined a specific type there. So okay, so but now we can't access this because it is not there. Of course not. So we need the canvas to be given out by this mutex, exactly the same way as before, but we don't need it there. And then I guess after that we could directly drop the canvas again, I guess, just in case we are doing more operations later on. But essentially I guess, and let's see what it's doing there. It's rendering the pixels and then it's writing the output, and okay, it at least did something. So where is my output? Okay, it did create output. Let's remove the ppm for now, as we are not creating it anymore, and let's do this again. Of course, I now have no idea if this was really faster than before. I guess we need to check maybe with a bigger image. So yeah, let me delete this image as well, just to be sure that it is really created and written, because I'm quite astonished. There it is. Okay, that it should be so simple to actually parallelize this. So yeah, I guess this is working then. So can we actually do something like, I would love to parallelize over my y's as well. Yeah, maybe first let's check out if this is really faster or if it's not. So I guess we can do something like we did before. We could pump up the bitmap a lot by 4096 pixels times 4096 pixels. This should take some time then. So I guess first I would like to do here into iter, which should actually change nothing, but now only use one thread again. So let's first time this one. And as it is going to take quite some time, as you can see, let's imply a certain magic of editing. Magic! And there is our result. It took actually about 3 minutes to render this. 2 minutes and 56 seconds. So you can be really glad that we just jumped through the time vortex and you didn't need to wait 3 minutes like I did. But now we have actually a very crude comparison here and can say into pariter again and do this again. And let's see how long this takes. And yeah, I guess we will run this again. And yeah, as I can just see on the moving bar, it's a lot faster. So yeah, but let's do some magic again. Let's jump through this time vortex again. Magic. And there we are, our result. Yeah, it was a lot faster. It was 3 minutes before, and now it only took 1 minute for us to render it. So this is actually working out quite nicely. Let's check that it actually rendered the right thing here. We have now our PNG here, and it is essentially correctly rendered as before. So maybe I can make this smaller a little so that you can see the whole picture. Yeah, I like that. So yeah, I guess we can try and optimize it further. How about because I noticed in the wandering of the bar that there were pauses when it was catching up with the line, or I'm not sure if it is that we are only parallelizing within these lines, so only parallelizing the columns, or if it is the accessing the canvas. Maybe we can optimize this as well. But let's first try and parallelize this iteration over this whole thing here for each pixel. So essentially what we are processing is something like, can't we create tuples somehow? Maybe tuples like this and that and so on. Can't we kind of create this? So XY tuples and process them? That would be awesome. So I know that we can create iterators, as we have seen here now, with one thing, but I don't think can we create. Let's just Google that, I guess. Rust iterator tuple. Is it possible to iterate over a tuple? How is this called? Itertools? Itertools. Okay, let's try this. So cargo search itertools. Itertools. Let's install them. Cargo TOML. There we go. Okay, we are adding more and more dependencies here, but yeah, why not? So how was it called? Cartesian product itertools, or what? It was. What was it called? Cartesian product. Hello, wasn't it called Cartesian? Cartesian product there. And how do I get information on this? Okay, I've used. Okay, they implement this on iterators. So do I only need to do something like include this and then maybe? Okay, let's try this, I guess, maybe. So if I understood this right, I should be able now to do something like Cartesian product here with this one. And then I should be able to call it like this and extract an X and Y here. Wait a second, is this really... Okay, I would have wondered this if this worked, but there is definitely something wrong. Okay, so there is somewhere I did a I missed I created some problem with parentheses. So let's remove those for now. We don't need those. And I guess we now have one too many here. So let's reformat this. Okay, it formats right up. Okay, method into Iterator exists for struct, Iterator tools product, and so on, but its trait bounds were not satisfied. Method cannot be called on Iterator tools product due to unsatisfied trait bounds. Yeah, oh, come on, let me see the whole message. Due to unsatisfied trait bounds, the following trait bounds were not satisfied. So Rayon parallel iterator. So we need some sort of okay, so if I don't do if I just call it par bridge here. Okay. Yeah. Maybe let's try this again and see if this works and how long it takes now. Let's see. And again, magic. Yeah. There we are, and it took us 1 minute and 4 seconds, and I guess this wasn't really much faster than 1 minute and 6 seconds. It didn't much of a difference there. It used all of the cores of my system. However, I don't get why there wasn't a difference. Maybe it's this par bridge thing. So in order to check this out, I would really much like to just check one thing, like this collect thing. I guess it should work. So let's try this again. So collecting this again, it tells us that it's missing what it is missing. Cannot infer type for type parameter B. So it does essentially not work. That does not know what should it. In what type of data it should collect this. So we just tell it that we are expecting a vector of u size thingies here, tuples. Not our tuples, but the Rust internal tuples. So now we should be able to do into Iterator here again. Yeah. With the difference that now in memory a map kind of is created of all of those Rust tuples with all these pixel coordinates in it. So yeah, let's try this again and let's see if this is faster. I have no idea, but let's see. And again, let's jump through the time vortex again. Whoosh! There we are. So it took mostly the same time, so I guess there isn't much of a difference. So let's get back to this. Let's get back to this par bridge thingy here. I like this better. So now let's check. Even though we have quite optimized it in a way that I wanted, but let's check if we can make it maybe even faster. If this mutex thingy here is holding us up because the different threads are waiting. To write into the canvas and therefore not processing data. Maybe we can exchange memory consumption for, let's see, processing time at this point. So maybe we can do something like, yeah, maybe we could do something like let intermediate result equal. And we want now a map here, I guess. So we can actually return something from this thing here, and we could simply, instead of writing this pixel, we could simply return a tuple, a Rust tuple, not our tuple, which contains the coordinates and the color. So yeah, maybe we can do this. Can we do this? Let's see. Let me comment this out. Why is now everything red? Mismatch type, expected tuple found. Yeah, okay. Yeah, okay. Okay, I see. So now I need to, if we haven't hit, I need to return something as well. So maybe we just return the X, Y, and none here. So maybe we return an optional and put a sum in here. So this would be an unreachable statement. Yeah, I guess it would. So let's let's do this before this. Yeah, I guess let's do it before this. We won't really see the difference. So now we are returning this data structure, which should now be a vector, and then let's see. Let's maybe not put this canvas in a mutex anymore. Yeah, but it shouldn't much. We can remove it later on if we essentially really need it for something else. So now let's get this one here and do intermediate result. Let's put this into an, let's create an iterator out of this. Let's get a mutable result from this. And let's simply do a for, yeah, I guess X, Y, color. Yeah, X, Y, color in this result set. We are doing some pattern matching here. Let's do pattern matching on the color here now. And if we have some color, we are just doing canvas write pixel x.y.color. And if we have none, we are essentially doing nothing. Can I not? Okay, there needs to be a comma. Can I do a comma here? No. So what am I, how do I specify that I don't want to do anything there? Okay, empty parenthesis. So I don't want to do anything if it's not, okay, so this is not working. It's Rayon, Iterator, collect. Okay, so I guess I need to, at the end of this, I then need to do a collect, I guess. Or can I even, just wait a second, couldn't I even just leave this out there and it gives me an iterator which I can then use? Is not an iterator, no. No, okay, this doesn't seem to work. Can I do into iter here? No, doesn't work as well, so I guess we collect this. And then, oh, can we then just iterate over this? Type error, what? Yeah, so now we should have written into canvas if this works, and then we should be able to write this information out. Let's just try this if it compiles. It doesn't. So what's the problem here? Type annotation needed. It doesn't know what the intermediate result will be. Yeah. Okay, so I guess there needs to be an iter then. It won't help because it doesn't know the type, but we can, I guess, specify this here. We want it to be a vector of usize, option, color, tuples, I guess. So yeah. And this one is mismatch types, expected usize found. Yeah, this is most likely right, because I need to dereference those there. Yeah. So let's try this. Yeah, and it's rendering. So again, let's jump through the time vortex and everything done. Yeah, but we see it didn't get really much faster. So it is mostly the same. So actually getting this mutex lock for the canvas isn't a problem, or it's not taking much time. So yeah, I don't think playing around with it, we can get it a much faster now. So let's just make these changes or revert those changes we had there again. So yeah, so we made things faster quite a lot by essentially tripling the speed by using all of our processing cores. And I guess we could get it a lot faster by profiling now, but maybe we will do this in the future, but not now. We just wanted, we set out to create multiple threads and process everything simultaneously and in parallel, and I'm really loving how easy it was using this Rayon library to do exactly that. And how this mutex works in Rust, I like it. It's quite nice. I like the way we are now iterating over our coordinate space. Maybe we could put some comments here to show which one is which. So we are first creating X and then a Cartesian product with Y, and then we have this here now, and we can do all of this stuff in parallel. We render it, we acquire the mutex, rewrite the pixel, and at the end we are getting all of this, converting it to a PNG and writing it out. And it is it's just awesome. I love that. So let's commit this actually. So let's actually add those cargo files, edit Rayon for parallel processing and iter tools to create Cartesian product. I love the simplicity of Rayon to easily parallelize our ray tracing. Awesome. So let's now add our chapter 05 and commit that. Used Rayon to parallelize ray tracing our sphere. Awesome, just awesome. And let's push this, I guess. Yeah, we need to. Or we could have even, maybe I shouldn't have even pushed this in a branch now. I could have I could have merged this now. So yeah, I guess I will do this. Git checkout main, git merge, experiment parallel there, and git push this one. And let's git branch minus, come on, git branch minus D. Let's remove our experimental parallel branch locally, and let's actually push, I guess it is origin minus minus delete experiment parallel, if I remember correctly. Yeah, and there I have removed this remote branch as well, and we have this parallel processing in here. I like that. Thank you for joining me during this next evolution of the Raytracer we are writing in Rust. I think what we did now in this bonus session will be helping us quite much in the future. Because it will speed things up as we are further moving along. And yeah, please subscribe to my channel if you want to watch something like this in the future and want to be informed when I publish new things. As I've said before, I'm trying to publish one of those videos here from this series for now every week. I hope this works out. Please give this video a thumbs up if you like it and videos like this, and I will see that I will produce more of them in the future. So yeah, thank you for joining me again and see you next time. Bye!